So I'm going to give a quick demonstration on how to run the flame photometer. The first step is we turn on the flame photometer, make sure the gas is turned on. We go down, turn on the flame photometer. So it'll take a few minutes for it to just prime the pumps, and it dispenses a little bit of cesium into the mixing chamber there. One of the things to be aware of is there is a trap here that has to be filled, or propane and mixtures will actually come out of there. So you can get a syringe and insert an amount or inject a certain amount of anything, water, whatever, just so the trap prevents the backflow of gases from the sample chamber. Okay, so the next thing we want to do is turn on the flame, or ignite the system. So it takes a couple of seconds. It'll ignite. You'll hear it start up with a nice whoosh. It'll say it's busy, wait a few minutes, and prime some of the pipes, test the sample mixing chamber, as well as the sample feed or sample pickup there. So it'll take a few minutes. Sometimes it does it once or twice. You can see over on the side here some of the water that didn't make it into the burning sample chamber dropping down into a reservoir that we have underneath the flame photometer. So once it's happy that it's started up, the next thing we'll do is select urine, auto sample, and auto cal, and that will start the sampling. It'll calibrate itself and then go through and pick up all the samples and give us results. It's just filling up the mixing sample chamber there, or sample feeder there, because it's starting to get a little low. Once the busy sign disappears, we can actually start sampling. You just have to make sure that you have enough cesium dilute over there. If you run out during a sample run, it may cause the machine to stop working for a little while. So remember to keep that cesium dilute filled up during operation. If it shuts down because it runs out of cesium dilute, the remainder of the samples will be skipped over, and sometimes you'll get some condensation in the burning chamber and the sample chamber, and you'll have to turn off the machine, either let it dry out or go in there and remove the chimney, the glass chimney, Pyrex glass chimney, and clean it. I would not suggest removing the Pyrex glass chamber unless you have to. If you break it, you're pretty much out of luck on this machine. They don't make those parts anymore. Okay, so now it's the busy signal has gone down. So what we can do is we can select urine, auto sample, auto cal. Printer. Urine, auto sample, printer, auto cal. And then the machine starts up. It takes a calibration amount, which is 100%, 100, what is this? Millimoles of sodium, calcium, and 100 millimoles of potassium, calcium. And feeds it into the mixing chamber, mixes. So what it does first is it takes, with this large piston here, it takes a sample of the cesium, and then there's a valve back here, an automatic valve that switches over, and it mixes it down here with a sample that it pulls up into the sample syringe here, and then both of them are poured into the mixing chamber. It's mixed, and then the sample arm will go in there, pull up the sample. The sample is pulled up using an aspiration system at the inside the burning chamber. What happens inside that chamber is the compressed air is blown across the feed pipe that is the other end of this pipe, and it creates vacuum. Pulls the sample into the chamber. It's mixed with propane and then ignited and burned at the top of the chamber. Now this system obviously doesn't, the sample feed is going to be irregular because it's using aspiration. The way it normalizes the readings is the cesium dilute. So the cesium dilute, which is usually not, nobody should have that in a urine sample, is used by the machine to normalize each readings, to know what quantity it's actually testing. So when it burns the sample in the burn chamber, it has 4 sensors around the perimeter of the chamber, and each sensor measures a different frequency of light. So it measures, one will measure sodium, which is a yellow light, cesium, potassium, and lithium. So it's just read in the 100 now distilled water, which is 0. So it nulls it to 0. You saw previously it nulling it to 100. So sooner or later, that's going to come up as 0. Now, if there's too much sodium in the water, you may get this failing. And 2.3 is kind of high. But okay, it was happy with that. So now it goes to the first sample, pulls in some of the cesium dilute right here. Then the valve switches over, and this also pulls out a sample. And so now the pistons move up, and the cesium dilute plus the sample is poured into the chamber here. It's mixed once again, and it is pulled into the burning chamber. And it'll continue, and you'll see the results. This one should be about 250. Yeah. Yeah, this one that's being put in right now, it should be 250. So let's see how once it starts sampling it. Now the machine doesn't like readings that are over, I guess this is 200. The machine doesn't like readings that are over, somehow didn't get that first sample. That's why 250 didn't show up. So this is the 200. I don't think I had the level of the sample high enough and it missed it. So that's why it showed next to nothing there, because it got no sample. This one, about 200. It waits for it to stabilize, and then it'll print it out. And it's already got the other sample in the needle here, and it's going to put it into the mixing chamber. And so this one is, I believe, 140. And that continues until it reaches all the way around to the second calibration right here. And then it'll continue around the tray, and then it'll do one final calibration at the end. So I have only 12 samples plus the calibration. It's going to do the 12 samples calibration and then go around to the calibration one more time, and then it's going to finish. So that's 140, and the next one should be, I think, probably 100. It goes relatively quick, and we have 2 of these machines so that we can handle maybe 4 to 8 classrooms of students doing tests. So yeah, this one's going to be what, a 100? Yeah. Now there's a little bit of inaccuracy, but if you consider the sampling method and stuff like that, I mean, that is pretty good. 100.5. Okay.